Good morning, dear students. Welcome back to physics class. Today, I would like to present the topic Errors in Measurement Part B. The subtopics are absolute error, relative error, and percentage error, and second one is combination of errors. In last class, you learned about the errors. What are the errors? The term error means an uncertainty produced in result from an experiment for measuring a physical quantity. Today class, you are going to study other types of errors. There are various types of errors that can happen in our common day-to-day life. Now I introduce main four types of error here. First one is absolute error, second one is mean absolute error, third one is relative error, and fourth one is percentage error. Before I going to discuss these arrays one by one, at first you have to know what is the importance of arithmetic mean of measurements of a physical quantity. What is important in measurement of a physical quantity? Its significance is that in absence of any other method of knowing true value of a physical quantity, we can consider arithmetic mean as the true value. Let me see the method to calculate the arithmetic mean of a physical quantity. Suppose the values obtained in several measurements of a physical quantities are A1, A2, A3, etc. An. Here, n observations are done and the readings or measurements are given. The arithmetic mean of these values is taken as the best possible value of the quantity under the given conditions of measurement. Because the arithmetic mean of the measured values would come very close to true value of the measured physical quantity by minimizing least count error, which you had studied in previous section. So its arithmetic mean, which is represented by A mean is equal to sum of measured values divided by number of measured value is equal to A1 plus A2 plus A3 plus etc. plus An whole divided by n, which is equation number 1. So, A mean is equal to I is equal to 1 sigma n Ai divided by n, which is equation number 2, where sigma I is equal to 1 n Ai be the sum of these measured values. Small letter n be the number of measured values of the physical quantity A and sigma be the summation symbol. Here we used the mathematical operation summation and this operator is represented by sigma I is equal to 1 n Ai, which means that summation is taken over n number of measured values of the physical quantity A. Assume that Ai be any measured value of the physical quantity by using the condition I is equal to 1 and summation of n values of Ai gives the arithmetic mean of measurement of the physical quantity A. Now I am going to discuss on absolute error, mean absolute error, relative error and percentage error. First one is absolute error, which is represented by modulus of delta A or mod of delta A. What is absolute error? It is the difference between the measured value and true value of a physical quantity. The magnitude of the difference between the true value of the physical quantity and the individual measurement value is called the absolute error of that measurement. This is denoted by modulus of delta A, and remember that modulus of delta A will be always positive. You know that a simple error of measured value of a physical quantity means difference between its true value and the measured value. It may be positive or negative. Then the errors in the individual measured values are delta A1 is equal to A mean minus A1, delta A2 is equal to A mean minus A2, delta A3 is equal to A mean minus A3, and so on till delta AN is equal to A mean minus AN, where A1, A2, A3, etc. A1 be the measured values of the physical quantity A. Here we consider the arithmetic mean as the true value. Then delta A calculated above may be positive in certain cases and negative in some other cases. But you have to remember that modulus of delta A, that is absolute error, will be always positive. Second one is mean absolute error. Its short form is MAE, and it is represented by delta A mean. What is mean absolute error of a measured physical quantity? It is nothing but the arithmetic mean of the magnitudes of absolute errors in all the measurements of a physical quantity. Mathematically, it can be written as delta A mean is equal to sum of all the absolute errors of these measurements all divided by number of measured values. So, delta A mean is equal to I is equal to 1 sigma n delta AI divided by n. If you do a single measurement, then the value you get may be in the range of A mean plus or minus delta A mean. That is, the single measured value A is equal to A mean plus or minus delta A mean, or A mean minus delta A mean less than or equal to A, less than or equal to A mean plus delta A mean. This shows that A is greater than or equal to A mean minus delta A mean, but A is less than or equal to A mean plus delta A mean. This implies that any measurement of the physical quantity A is likely to lie between A mean plus delta A mean and A mean minus delta A mean. Third one is relative error, which is represented by RE. The relative error is the ratio of mean absolute error delta A mean to mean value or arithmetic value A mean of a measured quantity. That is, relative error is equal to delta A mean divided by A mean. And fourth one is percentage error, which is represented by delta A. When relative error is expressed in percent, it is called its percentage error. Then percentage error delta A is equal to delta A mean divided by A mean into 100% or relative error into 100%. See the general calculation of percentage error of an experimental measurement of a physical quantity. Percentage error is equal to modulus of accepted value minus experimental value divided by accepted value into 100, where the accepted value be true value or arithmetic mean and experimental value be the measured value. Let VA be approximate or measured value of a physical quantity and VE be the arithmetic mean or exact value or true value of this quantity. Then absolute error is represented by modulus of VA minus VE. So its percentage error is equal to modulus of VA minus VE divided by VE into 100%. That is absolute error divided by the arithmetic mean or true value of the physical quantity, which is multiplied by 100, or its relative error is multiplied by 100. On next, I am going to take the subtopic combination of errors. What is the importance of studying the subject combination of errors? What is its importance in measurement? If we do an experiment involving several measurements, we must know how the errors in all the measurements combine. For example, density is the ratio of the mass to the volume of a substance. If we have errors in the measurement of mass and of the sizes of dimensions, we must know what the error will be in the density of the substance. Here, division is the mathematical operation we use to get the density of that substance, since density is equal to mass divided by volume. For this type of calculations, we should learn how errors combine in various mathematical operations. For this, we should use the following procedure. First kind of combination of errors is the error of a sum or a difference. When two physical quantities are added or subtracted, the absolute error in the final result is the sum of the absolute errors in the individual quantities. Let Z be the sum of two individual physical quantities A and B respectively. Then it can be written as Z is equal to A plus B. We have by addition Z plus or minus delta Z is equal to A plus or minus delta A plus B plus or minus delta B, which is equal to A plus B plus or minus delta A plus or minus delta B, or plus or minus delta Z is equal to plus or minus delta A plus or minus delta B, where delta Z, delta A and delta B be their respective errors. Then the maximum possible error in Z, delta Z is equal to delta A plus delta B, since Z is equal to A plus B. For the difference, Z is equal to A minus B. we have z plus or minus delta z is equal to a plus or minus delta a minus b plus or minus delta b, which is equal to a minus b plus or minus delta a plus or minus delta b, or plus or minus delta z is equal to plus or minus delta a plus or minus delta b, since z is equal to a minus b. So the maximum value of the error delta z is again delta a plus delta b. So, the maximum possible value of the error delta z in the quantity z is equal to delta a plus delta b. Here we have considered the positive value only, as the error be the absolute error. For the error calculations of the sum and the difference of two physical quantities, this rule is used. When two physical quantities are added or subtracted, the absolute error in the final result is the sum of the absolute errors in the individual quantities. On next, let me discuss on how to calculate error of a product or a quotient of two physical quantities. When two quantities are multiplied or divided, the relative error in the result is the sum of the relative errors in the multipliers or dividers. Suppose Z is equal to A into B, and the measured values of A and B are A plus or minus delta A and B plus or minus delta B. Then Z plus or minus delta Z is equal to A plus or minus delta A into B plus or minus delta B. Here we have to use this mathematical operation or property as A plus B into C plus D is equal to AC plus AD plus BC plus BD. Here the result is AB plus or minus B delta A plus or minus A delta B plus or minus delta A delta B. Dividing LHS by Z and RHS by AB, we have 1 plus or minus delta Z by Z is equal to 1 plus or minus delta A by A plus or minus delta B by B plus or minus delta A by A into delta B by B. Since delta A and delta B are small, we shall avoid the terms delta A by A and delta B by B. Then we will get the maximum possible relative error as delta Z by Z is equal to delta A by A plus delta B by B. This rule is also applicable for division. Here the rule is when two physical quantities are multiplied or divided, the relative error in the result is the sum of the relative errors in the multipliers or dividers. And last error calculation part is to calculate error in case of a measured quantity raised to a power. Here the rule used shows this property as the relative error in a physical quantity raised to the power k is the k times the relative error in the individual quantity. Suppose Z is equal to A square. Here we have to find the physical quantity Z by squaring the physical quantity A. Then delta Z by Z is equal to delta A by A plus delta A by A, which is equal to 2 into delta A by A. Here, it used the similar property to calculate the error in the result by multiplying two physical quantities A and B, which was done in previous session. Hence, the relative error in A square is 2 times the error in A. For this clarity, you see this example. If Z is equal to A, the power of P, B, the power of Q, divided by C, the power of R, then delta Z by Z is equal to P into delta A by A plus Q into delta B by B plus R into delta C by C. Once again, I repeat the rule which shows the property in this operation as relative error in a physical quantity raised to the power k is the k times the relative error in the individual quantity. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.